Hello, we are Team Formula One, and this is the Ferrari, a line-following robot designed to teach 8 to 10-year-olds about electronics and robotics. The idea is simple. A cat-themed car traces a black line on a white floor.
Beneath the friendly exterior lies a carefully engineered 5-system architecture, sensing motion, audio, visual, and power, all controlled by an ESP32 microcontroller. Our goal for today is to show how each subsystem works together and to create an engaging educational tool that costs less than $100 to build.
The Ferrari uses 3 infrared emitter receiver pairs to detect the contrast between a dark line and a light background. We chose IR sensors because they ignore visible light and therefore aren't affected by ambient lighting. Each pair produces an analog voltage proportional to the reflectance. Values near zero mean black, higher values mean white. These signals give us real-time readings from the left, center, and right of the car. The microcontroller runs a simple algorithm to determine whether the car is centered, turning left, or turning right. If all 3 sensors detect black or the center sensor detects black, the robot moves straight. If only one outer sensor detects black, the car steers back towards the line.
Everything is powered by a single 9-volt battery and a small power distribution board. The battery feeds 3 separate rails, a 5-volt rail for the LCD, amplifier, and sensors, a 3.3-volt rail for the microcontroller and logic, and an unregulated rail for the DC motors. We used buck converters and regulators to provide stable rails and added a low battery indicator and load switches so each subsystem gets the right voltage without overloading the battery. To enable operation, we flip a single power switch. The exposed PCBs and labeled rails make it easy for children and educators to trace how power flows through the system. Safety was a priority. The battery compartment is secured, and all sharp edges on the chassis are rounded or covered.
The Ferrari drives using 2 DC motors mounted at the front of the robot, controlled independently with pulse width modulation. When the sensing subsystem reports that the car is centered, both motors drive at the same speed and the car drives straight. If the car drifts to the right, we increase the right motor's duty cycle to speed up the right wheel and turn the car left until it is realigned. When it drifts left, we speed up the left wheel to turn right and realign. By repeating this process, we can ensure the Ferrari is capable of following the line throughout the entire course.
On the front of the car, there's an LCD that displays 2 cat eyes. The microcontroller swaps the graphics based on the robot's direction. When centered, it looks straight ahead. When turning left, it glances left. And when turning right, it glances right. Kids can immediately read the cat's expression and understand whether the robot is centered or correcting. Complementing the eyes is a soundtrack. The audio subsystem uses pulse width modulation to generate musical tones and play a simple melody through a small amplifier and speaker. Together, the eyes and the music bring the Ferrari to life, making it more engaging for children.
Behind the scenes, the Ferrari's behavior is driven by a lightweight control program running on the ESP32. We designed the software to evolve alongside our testing process, starting with simple sensor checks and eventually growing into the full line-following experience. We began with the sensor-only mode to verify that each IR pair was reading black and white correctly. The LCD eyes would mirror the readings, giving us immediate visual feedback without needing the motors. Once those readings were stable, we added the decision logic. The microcontroller continuously compares the left, center, and right sensor values and chooses one of 3 actions: go straight, correct left, or correct right. The final layer was the personality. We integrated audio, eye animations, and low battery indicators into the same loop so everything feels synchronized. While the full implementation is simple, the result is a robot that reacts smoothly in real time and feels responsive and alive to the user.
The culminating result is an engaging, low-cost educational tool that can inspire the next generation of engineers and scientists. In its current form, the Ferrari successfully meets all of our engineering requirements.
The Ferrari can sense black and white surfaces, runs from a single battery, controls its movement, provides audio and visual indicators, exposes its PCBs for learning, powers on quickly, and stays under the $100 BOM limit.